Scale drawings. Scale drawings are used to represent objects that are either too large or too small for a life-size drawing to be useful. Scale drawings are similar to the object that they represent. Here are some examples. A life-size drawing of an ant or an atom would be too small to be useful. A life-size drawing of the state of New Jersey or the solar system would be too large to be useful. A scale is always provided with a scale drawing. The scale is the ratio of the drawing to real life. When solving a problem involving scale drawings, you should write the scale as a ratio. Write the second ratio by putting the provided information in the correct location, drawing on top and real life on bottom, and then solve the proportion. This drawing has a scale of 1 to 10, so anything drawn with the size of 1 would have a size of 10 in the real world. So a measurement of 150 millimeters on the drawing would be 1,500 millimeters on the real horse. The distance between King Mswati III International Airport in Eswatini and OR Tambo International Airport in Johannesburg, South Africa, is 431 kilometers. You look on a map and see the scale is 1 centimeter to 100 kilometers. What is the distance between the two cities on the map? Let's write the scale as a ratio to set up the proportion. Alright, so drawing over actual is going to give us 1 centimeter per every 100 kilometers. So this is what we're trying to figure out. What is the distance on the map in the drawing? So that's our x, that's what we're trying to find. The actual distance is 431 kilometers, and here's our ratio. 1 centimeter is to 100 kilometers. So we're going to cross multiply, divide by 100 to solve for x, and we get 4.31 centimeters. On a map, the distance between Pigs Peak, Eswatini and Lavumisa, Eswatini is 4.7 centimeters. The scale is 1 centimeter is to 50 kilometers. What is the distance between the two cities? Alright, 4.7 centimeters in the drawing is to an unknown distance in real life, as 1 centimeter is to 50 kilometers. So we're going to solve for y. Cross multiply, divide both sides by 1 centimeter, and we get 235 kilometers. Scale drawings can also be used to enlarge shapes, photographs, models, etc. There are a few steps required to enlarge a shape. Measure all of the angles and all of the sides. Using the scale and proportions, calculate the lengths of the new sides. Draw the new shape with the given angles and the new side lengths. Let's try a few examples. Enlarge the rectangle below if the scale is 2 to 5. Alright, so first we need to measure all of the angles and all of the sides. The angles, that's easy. This is a rectangle, so the interior angles are all 90 degrees. Alright, we're going to use the ruler to measure the sides. So this side is 3, and the other side, oops, let me rotate that. The other side is 2 centimeters. So all of the angles are 90 degrees. The length measures 3 centimeters. The width measures 2 centimeters. Using the scale and proportions, calculate the lengths of the new sides. Alright, so the ratio we want is 2 to 5. So if it's 3 in the diagram, what's it going to be in our new scaled up version? That's x. Cross multiply, divide by 2, and we see that the long side of the rectangle will be 7.5 centimeters. We do the same thing with the short side, 2 centimeters. Cross multiply, solve for x, and we get that the short side of the rectangle will be 5 centimeters long. Then, using your ruler, you can draw the new shape with the given angles and the new side lengths. So, here you can see that the long side is 7.5 centimeters, and the short side is 5 centimeters. Enlarge the triangle below if the scale is 1 to 3. Alright, so we want to make this triangle 3 times larger. First, I'm going to come over here and measure the sides. Alright, So this side is 3 centimeters. Oops, I moved the ruler. Alright, this side is 3 centimeters. Flip my ruler up. That side is 4 centimeters. And therefore, the hypotenuse is 5 centimeters, but let's measure it to be sure. It's a right triangle, it's a 3, 4, 5 triangle. Alright, 5 centimeters. Great. Okay, so let's use our scale factor 1 to 3. We want it to be 1 to 3. So if the small one is 3, what is going to be the large one? So cross multiply, we get x equals 9. Okay, let me just do all the math up front. Okay, so this side here, if we want it, the scale is 1 to 3, the original is 4, so what's the new one? X equals 12 centimeters. And then finally, our scale is 1 to 3. If the small version is 5, what's the large? X equals 15 centimeters. Okay, so let's make our ruler vertical and draw our short side here, which is going to be 9 centimeters. Actually, I'll do it as a line from here to here. Okay, now I'm going to flip my ruler around and draw my next line, which is going to be 12 centimeters. Okay, like that. And then finally, I'm going to connect this point with that one, and you can see it's exactly 15 centimeters. Okay, now I'm just going to make sure that's a 90-degree angle by throwing my protractor in here, flipping it around, and yep, you can see that is a 90-degree angle. And now I'll just label the sides. This one is 12 centimeters. Move that. This one is 15 centimeters. This is 9 centimeters, and that is a right angle. And there you go. The 3, 4, 5 triangle has become a 9, 12, 15 triangle, 3 times larger. Enlarge the triangle below if the scale is 1 to 2. Alright, so I'm going to take my ruler and flip it this way. Now the original is 12 centimeters long, which means this side, I'm going to label it 12 centimeters. It's going to become 24, right? So if the scale is 1 to 2, that would mean if the original was 1, then what is going to be the final length? Cross multiply, and we get 24 centimeters. So how do I even fit that? Okay, let's see. We'll put it down here. All right, so here's our line. That's 14. And now I need 10 more. Move my compass, or my protractor, sorry. We need 10 more. Okay. There we go. This is now a 24 centimeter long leg. Now I'm going to get that 90-degree angle by using my protractor. I'm going to put the right on the dot and swing it around till it's at 90 degrees. All right. Now I'm going to draw a line this way. Now I need to make this line a very specific length. Let's figure out what length. So this side is currently 5 centimeters, which means it's going to be 10 here. But just so you can see why, if it's a scale of 1 to 2, that would mean if the original is 5, what's the new one? Cross multiply, and we get 10 centimeters. So I'm going to move my ruler to 10. Oh, I'm running out of space. Okay, maybe I can move all of this up a bit. This is 10 centimeters. All right. 10 centimeters, and we used a protractor so we know that this is a right angle. Right there. And then I'm just going to connect those two endpoints with the hypotenuse. Now, what is the hypotenuse? It's 13, but let me just verify, because this is a special triangle. This is a 5, 12, 13 triangle. So 13 will become 26 when we double it, right? So if it's 1 to 2 and the original is 13, that would mean we cross multiply and we get 26 centimeters. And there's our triangle. And here is the solution.